In this section, we're going to look at different types of elements. We are going to look at metals, nonmetals, and metalloids. So metals all have certain properties in common. They're called metallic properties. So they can conduct electricity and heat. They can be hammered into sheets. They're malleable. That's the word for that. We learned in our physical properties. Metals can be stretched into wires. They are ductile. They have a shiny appearance. And all metals except for mercury are solids at room temperature. So some examples could be sodium, lithium, potassium, copper, iron, zinc, and we could go on and on and on. A lot of the elements on the periodic table are metals. And you can see these in your textbook on page 197. Let's take a quick look at that. Actually, I'll just flip to that, and you'll be using that to color the periodic table in your package. So page 197. So right here, we could see that everything in blue is a metal. So most of the periodic table is made up of metals, right? All right, second, we're going to look at nonmetals, and if you see, they are the ones in yellow. So they are to the far right of the periodic table, except for hydrogen. And hydrogen is one that can act as a metal and a nonmetal, which is why it's not even attached to the periodic table. It's its own special group. But for now, we're going to say it's acting as a nonmetal. So nonmetals have their properties. They are nonmetallic properties, and they tend to be the opposite of metallic properties. So with nonmetals, some are gases. One is a liquid. Bromine is a liquid. They are very brittle if they're solid. They cannot be stretched into wires. They are not very shiny and do not conduct heat or electricity. So some examples would be oxygen, nitrogen, fluorine, neon. You could choose any other ones. Oh, that's not an Fe. That's just fluorine. Fluorine. Okay. And then we have metalloids. And metalloids are in green on your periodic table. And if you see, they're in the middle between the metals and nonmetals. So they have properties of both. So, for example, they have some metallic and some non-metallic properties. You have to look at them on an individual basis to know exactly what their properties are. So some examples would be silicon, germanium, and boron is another example. The ones in green on your periodic table. So in your package, you have a periodic table, and I'd like you to color it in as you saw on page 197. So use page 197. I just realized you weren't able to see all that. Page 197 to color your periodic table. And you can indicate the metals, nonmetals, and metalloids. Okay? So this is part of organizing the periodic table. The fact that we have metals, nonmetals, and metalloids, this is how we organize the periodic table. And it was John Dalton that discovered that each element had its own kind of atom with its specific atomic mass. And this is how he organized the periodic table, was according to atomic mass. So he made up a card for each element and he listed everything he knew, and then he put them on the wall according to increasing atomic mass. And he made them in vertical and horizontal rows. By doing this, he noticed a pattern in the properties of the elements. There were patterns which had developed in a periodic fashion. So for example, every seventh element had similar properties. And then he reshuffled things around and left spaces where necessary, which later were elements that were discovered. And he actually predicted their properties as well. So he called this the periodic table. Okay, so once you've colored your periodic table, as I indicated, you can also, I'd like you to write down which ones are solid, liquid, and gas at room temperature. Indicate which ones are liquid and gases. The rest of them are solids. Okay, so other ways that elements got organized. So originally they looked at organizing them according to atomic mass, and then in the modern periodic table they realized that it wasn't quite right, and so the modern periodic law said that if the elements are arranged according to their atomic number, a pattern can be seen in which very similar properties occur. So Mendeleev wasn't quite right. He was pretty close, but it's actually according to atomic number. And the modern periodic table is organized into vertical columns called families or groups, and horizontal rows called periods by atomic number. So in a group, it's a set of elements in the same column, and the column is up and down. And we call that a chemical group. And they have very similar physical and chemical properties. Their behavior can be explained by their atomic structure. They have the same number of electrons in their outermost orbit. So it's the number of valence electrons that determines the properties of the group. The first group we're going to look at are the alkali metals, and those are in the first column. So you can highlight your column as well. So they all have metallic properties. They're very reactive, so they get stored under oil or kerosene. They react with water to form basic solutions in hydrogen gas, and they also react with group 17 to form salts. So group 17 is these guys here. So what's a salt you've heard of? I'm sure we know sodium chloride, right? So sodium chloride is an example of a salt that gets formed from group 1 and group 17. The next group we're going to look at are called the alkaline earth metals. And the alkaline earth metals are in column 2. Now they also have metallic properties and are still very reactive, but not as reactive as the alkali metals. They also would react with group 17 as well to form salts. So for example, I could say put calcium and chlorine together and form calcium chloride. So that group we've been talking about, group 17, they are called the halogens. And they are extremely reactive nonmetals. And they're a varied group because gases are fluorine and chlorine are gases, bromine is a liquid, and 2 solids, iodine and astatine. They're non-metallic and they're very reactive. We actually know fluorine to be the most reactive nonmetal. And as mentioned before, they'll react readily with groups 1 and 2 to form salts. So the next group we're going to look at is group 18. And group 18, they're called the noble gases. Oops, I almost colored the wrong one. It's this group here. They're all gases, non-metals, and these are very, very unreactive. So we use them in light bulbs and other situations where air needs to be kept out. They used to be called inert, unreactive, until 1962. Xenon hexafluoride was created, XeF6, xenon hexafluoride. A couple of special groups we'll look at. One is called the transition metals. Of course, you pause at any time to catch up to your writing. The transition metals, and they are all metals. They're groups 3 to 12. So that's in here, 3 to 12, right in there. Those couple of groups. They're all solid except for which metal is mercury. So that would be down here. And let's see something here. So they also form familiar structural metals. So for example, iron, nickel, and chromium, and some are used for jewelry and currency. Copper, gold, silver, platinum, we call them the precious metals. And the compounds of these metals are often very colorful. I'll have to show you a demo of some of these reactions. Another group we've talked about already are the metalloids. And these are the ones around the zigzag line or the staircase. And they have the properties of metals and nonmetals. So we had boron, silicon, germanium. Notice not all of them that touch it are a semi-metal or metalloid. Arsenic, antimony, tellurium, polonium, and acetine. Those are our metalloids. The last feature we're going to look at are the periods. And the period are a horizontal row on the periodic table. As you go from left to right, there's a gradual change in properties, and the atomic number increases. The elements gradually change from being metallic, as we saw, to non-metallic. And then they end up with the noble gases. So that's a little bit about the periodic table. So you need to read this section, and I'd like you to do page 196, number 3, and page 206, number 7 and 8. Okay? That's it for now.